0.3, so that is 1.55. so this is the quantity. So this brace beams length is taken in between the columns inner face, because already while calculating the quantity of column, quantity of cc for columns, we have included the thickness or thickness of the column. So the deduction for the 0.3 width on either side will give you 4.3 for brace beams. You can see here the 4.3. 0.3 is the size, 0.3 is the depth, 0.3 is the width. So the quantity is 1.55. The next second brace beams, same 4.3, 0.3, 0.3 and 4 numbers. So if you multiply 4 with 4.3 with the width as well as the thickness, you will get the quantity around 1.55 cubic meters. The next next item is a ring beam. Ring beam, you can see here 4 and then 4 numbers of ring beams, 4.3, 0.4, 0.4, which is a 2.75. the quantity is 2.75. The next for cover slab, the size, the width of the cover slab is 4.9 by 4.9, so it is 1 in number. So thickness of the slab is 0.1 meters, so the quantity is 2.4 meters. The next, the quantity for bottom slab, so it is also same 4.9, but the bottom slab thickness is 0.2, so the quantity comes around 4.8. Then side walls are 4 in number. So the height, that means the quantity is calculated by taking the center line, total center line is 4.7. For one it is 4.7, so 4.7 multiplied by 1.8 into 0.2, so this quantity comes around 6.77. so the next one is refilling the foundation trenches with excavated soil. So the refilling of foundation trenches, this quantity is obtained by deducting the quantity of cc bed, quantity of RCC for footing, and also quantity of RCC for columns below the ground level. Now you can see here the item is obtained by deducting the item 2. Item 2 is cc bed for footings. Item 3a is the quantity of rectangular portion of the footings. Quantity 3b is item for trapezoidal portion. Item 3c is quantity for columns below the ground level, and quantity of earthwork excavation is item 1. So that is 20.07 minus 2.07 minus 0.8 minus 2.11 minus 0.486. So the total quantity comes around 14.604 cubic meters. And this is the refilling the foundation trenches with excavated soils. The next, supplying, bending, tying and placing in position MS grills for all RCC works, including cost of steel, fabrication charges, cost of binding, wire, etc. complete. These items are calculated as follows. For footing, the quantity of steel is taken as 500 Newton per cubic meter. So the total quantity multiplied by 500, so that quantity is 1455. So similarly, for columns at 1500, the quantity is 4 multiplied by 1500. So for 1 cubic meter it is 1500. So 4 into 1500, 6000. Similarly for braces at 1000 Newton per cubic meter. So 3.1 into 1000, 3100. Similarly for ring beams at 1200 Newton per cubic meter, the quantity is 2.752 into 1200. So that comes around 3302 newtons. Similarly for floor slab at 1000 Newton per cubic meters, the quantity of steel is 4.8 into 1000, 4800. Then for side walls it is taken as 75 Newton per cubic meter, 6.77 into 1500. So it is 10,155 newtons. Similarly, you have here total quantity is 3.28 tons. Then this supplying and fixing in position 1 number of CI manhole frame and cover of size 0.75 0.6 meter in the roof slab 1 number. The next supplying and fixing in position MS ladder 1 number. Then color washing and the exterior portion of the water tank LS, providing inlet and outlet service pipe connections LS, lump sum, LS means lump sum, unforeseen items at 2% lump sum. This PS and contingencies at 3% is taken, that PS is plumbing systems and contingencies taken at 3%. So this is the detailed estimation of RCC overhead tank. Now let us take some problems. Look at this picture here. One problem, a small problem, short questions. Calculate the quantity of RR masonry for side walls of tanks Lewis barrel showing in figure for a length of 10 meters. See here, this is the side walls of the barrel, trapezoidal in portion, 0.4, 0.3 meters is the top width, 0.4 is the bottom width, height is 0.8. So it is calculated as follows. The quantity of RR masonry for side walls is 2, 10 is the length, 0.3 plus 0.4 average width multiplied by 0.6. So this quantity is 5.6. So this is how the estimation of RCC slab culvert and RCC overhead tank, and some small problems on different items. So let us take one more problem here. Look at the picture. This is one truss problem. The truss consists of principal rafter. This is one principal rafter, this is one principal rafter, and this is the tie bar, and you have this one is a strut is 90 degrees here. Now let us calculate the quantity of the purlins principal rafter. So the principal rafter is AB and AC. Now length of the principal rafter. So length of the principal rafter is, if you take the triangle A dash B, so cos 30 degrees is equal to B A dash divided by AB is equal to 4.5 divided by AB. So AB is equal to B A dash by cos 30 degrees, which is 4.5 divided by cos 30, 5.2 meters. So 5.2 meters is the length of the principal rafter. So similarly, you can see here the length of the strut is this one GE. So sin 30 degrees, this one also strut, two struts are there, sin 30 degrees. If you take the triangle DFB, FD by BD is equal to FD by 3.0, FD is equal to 3 into sin 30 degrees, which comes 1.5 meters. So this is the length of the strut. So with this length we can calculate the quantity. So the quantity of steel for principal rafter is equal to 2 rafters with 5.2 into 108, which comes around 1123.2 newtons. Similarly, quantity of steel for struts, 2 struts are there, 2 struts multiplied by 1.5 is the length, 54 is the weight of the steel. So weight of the steel is multiplied with the length, total length, it comes around 162 newtons. So this is one small example on estimation of quantity of steel for a truss. So with this information or with this discussion we conclude today's class.